Good morning, guys. Today we're going to be looking at zeros and factors of polynomial functions. We've already looked at factors these past couple of lessons. Zeros we looked at, I think, in the first chapter, but another name for zeros are x-intercepts. So when we talk about zeros, we're talking about x-intercepts. Okay, so the objective today is we will be able to identify the relationship between the x-intercepts and the factors of a polynomial function. And again, we've been talking about factors. Those are the terms that we were working with in this past lesson in synthetic division and long division. These are the terms we were dividing by. And then when we were dividing polynomials, and we were factoring with GCF and difference of squares and table method, all those parentheses that we were working with, those are the factors. Okay, so let me scroll up here. Okay, so the introduction, in the last unit we started our study of polynomials. We have continued our study in this unit, and today we will look at the relationship between polynomial equations and their graphs. So below here we have some equations. And the difference that we're talking about, we're saying the word equations. When we use the word equations, it's whenever an expression is equal to 0. So equations are when we have expressions equal to 0. So for example, here we have an expression and it's equal to 0. So altogether we have an equation. Okay, so when I have an expression equal to 0, we have an equation. So here I have an expression x squared minus 4, it's equal to 0. So we call this an equation. This is another equation and another equation. And why are they called polynomials? Because poly means many, nomial means numbers or terms. So there's many terms, right? Here I have 2 terms, 3 terms, and then here I have 1, 2, 3, 4 terms. And then down here, if I scroll down, we have polynomial functions. And let me zoom out a little bit so you can see all of them. So we have a constant of degree 0. We've seen constant functions before. They're just horizontal lines. So constant functions, horizontal line. Then we have linear functions. These are equations that have maybe y equals mx plus b style functions. Then we have quadratic functions. These are functions that have x to the 2nd power. Then cubic functions are functions that have x. Sorry, I wanted to put an equal sign. X to a 3rd power. Then we have functions where it's equal to x to the 4th power. These are called quartic. And then if it's degree 5, that's to the 5th power. These are called quintic. Okay, so these are all functions, and we can see their graphs. We have horizontal line, we have a diagonal line for linear. Quadratic have a U shape. Cubic have kind of this S shape or like a snake. Quartic have like a W shape. And quintic have kind of like the power of 3, but with more turns, more curves inside. Now notice the degrees. Let me choose a different color. So if I have degree 1, for example, how many x-intercepts do I have? 1. Actually, let me just put the dot there. Okay, so I have 1 x-intercept. If I have degree 2, how many x-intercepts do I have? 1, 2. If I have degree 3, 1, 2, 3 for degree 3. Degree 4, I have 1, 2, 3, 4 x-intercepts. Degree 5, do you guys see a pattern? 1, 2, 3, 4, 5. The degree will tell you, or not calculate, but will tell you, how many possible x-intercepts the graph will have. It's pretty interesting, pretty nice feature, right? Okay. So now let's talk about zeros and factors, right? So let me go over to the next page. So we wanted to talk about zeros and factors, the relationship between polynomial equations and functions. So again, polynomial equations, when we talk about equations, they are equal to 0. So we actually have an equation right here. This is a related equation to this graph. Functions are, I guess you could say, the graphs, right? So this is the graph right here. So I have the function that's been graphed, and then over here is the equation, something that's been equal to 0. Okay, so the graph of the quadratic function is displayed below. The related equation for this graph is the following. Equation equal to 0. One way to generate this equation using the graph is to find the zeros, or sometimes they're called roots, but we know them as x-intercepts. So one way to generate the equation is by using the graph to find the zeros. So the zeros, the x-intercepts. Okay, so for example, in this graph on my right, I have an x-intercept at -4, and +2. So we're going to take these zeros and write them as factors. The factors can be multiplied together to generate the related equation. So this is the new thing that we're going to learn today, is how to change an x-intercept into a factor. How to change a 0 into a factor. How to change an x-intercept to a factor. Okay. So let me see. I'm probably going to zoom out again just to make sure I can see the the graph and what I'm writing. Okay. All right, so I have the graph. We were talking about x-intercepts, the zeros, so we're going to write the zeros here in this space. Right, so I have two x-intercepts, one at x equals -4, and one at x equals 2. Okay, so now I'm going to zoom in a little bit, just so that I can use the space that I have here. Right, so we're going to write these two zeros as factors. Now, to write them as factors, I'm going to copy one on the factor side. Let's copy that one first. And what we're going to do is we're going to do the opposite. So we're going to do, what's the opposite of a -4, -4? We're going to do +4 on both sides. And so that's going to give me x plus 4 on the left equals to -4 plus 4 is 0. So this is one of my factors here. This is a factor. Okay, then we're going to do the same thing with the 2. So I have x equals 2. What's the opposite of a +2? -2. So we're going to end up with x minus 2 on the left. Bring down the equal sign. What's 2 minus 2? 0. So this is my second factor. Okay, so I have two factors here. So going from zeros to factors, right? So the zeros are my x-intercepts on the graph up here above. Then I'm doing the opposite to get two factors. Then to get the resulting equation, I'm going to take those two factors, in this case, the parentheses x plus 4 and the x minus 2. So x plus 4 is coming from here, copying it over here. X minus 2, copying it over here. All right, so let me highlight them. So x plus 4, x plus 4, x minus 2, x minus 2. Right? And then we're going to multiply. So we're doing x times x, and then x times -2. So x times x gives me x squared. X times -2 gives me -2x. 4, sorry, I'm going to write it. 4 times x gives me 4x. And then 4 times -2. 4 times -2 gives me -8. Combine like terms here, -2x plus 4x. Get x squared plus 2x minus 8. So this is my resulting equation. But if I zoom out, doesn't this resulting equation look familiar? Isn't it this one right here? It is. It's x squared plus 2x minus 8, x squared plus 2x minus 8. So we're getting the equation from the x-intercepts. The x-intercepts were -4 and +2. Then we're making these x-intercepts equal to 0, by doing the opposite. Opposite of a negative is adding, opposite of a positive subtracting, giving us these two factors. Then we're writing these two factors, kind of multiplying them, and after you multiply them and combine like terms, we get the equation above. Right, and so the next part we're going to look at is the following. Okay. So the next part says, this polynomial function can also be represented in the table as shown below. So this is a table. We can identify the x-intercepts of the function represented in the table and write them as factors. So this is another way of looking at it. Instead of looking at a graph, they might give us a table. And how do we know what the x-intercepts are if we're looking at them in a table? So the x-intercepts are the ones that have y equal to 0. So these have y equals 0. So if I look at my table, do I have any x values where y equals 0? Yeah, I have 2. And so again, our x-intercepts are -4 and +2. So my factors are going to be, what's the opposite of -4? +4. And what's the opposite of a +2? -2. Okay, so these are going from x-intercepts to factors. Okay, so now let's slide over to the examples. Let's try out these examples. Zoom in a little bit more. Oh, too much. Okay. So it says for examples 1 and 2, find all the zeros of the polynomial functions. Okay. So to find the zeros, we're going to set each part equal to 0. So we're going to work backwards in a way. So it's asking us to go backwards. So let's say, let me highlight something. So this is one factor. This is another one. And we're going to set each one equal to 0 and solve for x. So I'm going to bring this one over here. It's 2x minus 1. Set it equal to 0. And this one, too far. This one over here, x minus 5 equal to 0. Solve for x. So +1, +1, 2x equals 1, divide by 2, divide by 2. So I get x equals 1/2. And then here I'm going to add 5. Add 5. X equals 5. So my zeros are 1/2, comma, 5. Right, so let's go to example 2. All right, so here we have three things to solve. We have this one, x, we have x minus 1, and we have x plus 1. So this one has three parts. So first part, easy, x equals 0. That's one answer. Comma, the next one is x minus 1 equals 0. Add 1, add 1. So x equals 1. Then the last one, x plus 1 equals 0. Subtract 1, subtract 1. X equals negative 1. So comma, negative 1. All right, so that's how we do it. So if I have a function and I have factors, 2x minus 1 is a factor, x minus 5 is a factor. If I set them equal to 0 and solve for x, my answers will be the x-intercepts. Okay, let's go to example 3. Identify the zeros and factors of the polynomial function represented in the graph shown below. So the zeros, again, those are the x-intercepts. So I have 1, 2, 3 here, and they're happening at x equals negative 3, at x equals negative 1, and at x equals positive 2. Positive 2. Okay, so how would I write them as factors? What's the opposite of a negative 3? So we would write x plus 3, x, for the second one, what's the opposite of a negative 1? Positive 1. And then the opposite of a positive 2, negative 2. Okay, so we have 3 factors, right? 1, 2, 3. Okay, part B. Right here. It says, write the equation of the polynomial function in function notation using the factors you found in A. Okay, so in function notation, it means I have to put f of x equals x plus 3, x plus 1, x minus 2. Okay, so I'm just copying the factors that we got there and writing them out as follows. And so we're just going to multiply out. So let me zoom into B so we can focus on B. Okay, so we're going to do x times x, that's x squared, x times 1, that's x, and we're going to do 3 times x, that's 3x, then 3 times 1, that's 3. X minus 2. Combine like terms. Over here, x plus 3x is 4x. Bring down the plus 3. And then we're going to do distribution again. So we're going to do x squared times x and then x squared times negative 2. That's going to be x cubed minus 2x squared. Then we're going to do 4x times x plus 4x squared. Then 4x times negative 2. That's negative 8x. Then 3 times x. It's positive 3x. And then 3 times negative 2. It's negative 6. Equals. And then the last thing, I'm going to bring down the f of x, because that's going to be my final answer. Combine like terms. So there's only one x to the third power. Negative 2 plus 4 is positive 2x squared. Negative 8x plus 3x. Right, because I have these two are like terms. These two are like terms. And so those two are going to combine to become negative 5x. And then just bring down the minus 6. And so my answer is the following. All right. That was what example 3. Okay, so let's go over to example 4. This one says, identify the zeros and factors of the polynomial function represented in the table shown below. So remember, zeros happen when y equals 0. So I have y equals 0 here, y equals 0 here, and y equals 0 here, and y equals 0 here. So I actually have 4 x-intercepts, 4 zeros. So I have x equals negative 2. Then I have x equals negative 4 over 3. Then I have x equals 1/2. And then I have x equals 3. Right. So if I'm going to write this as a factor, this one's pretty easy. This is plus 2 plus 2. Right? That's going to give me x plus 2 equals 0. So that's one factor. What about the other one, right? What's the opposite of dividing by 3? Multiplying by 3. That gives me 3x equals negative 4. The opposite of subtracting 4 is adding 4. So that's going to give me 3x plus 4 on the left equals to 0. So that's one factor there. What's the opposite of dividing by 2? Multiplying by 2. So here I get 2x equals 1. 2x equals 1/2 times 2 is 1. Then I have to do the opposite of a positive one, which is subtract 1. And I get 2x minus 1 equals 0. And the last one, the opposite of a positive 3 is subtracting 3. So that's going to give me x minus 3 equals 0. Okay, so these are my factors. Again, my zeros were x equals negative 2, x equals negative 4/3, x equals 1/2, x equals 3. Then let's go over to example 5. It says, for example 5 and 6, write the simplest polynomial function with the given zeros. So I have x equals negative 2, x equals 3. The opposite of subtracting 2 is adding 2. So that gives me x plus 2 equals 0. Then opposite of positive 3 is negative 3, so subtract 3. X minus 3 equals 0. So these two are my factors. So I can write them as x plus 2, x minus 3, x multiply x times x, x times negative 3, x squared minus 3x. Then 2 times x and 2 times negative 3, that's positive 2x minus 6. It's going to equal to x squared minus x minus 6. Or I can write it up here. Final answer, x squared minus x minus 6. Okay. Example 6, kind of the same idea again. So we have x equals negative 1, x equals 0, x equals 5. So the opposite of subtracting 1 is adding 1. It's going to give me x plus 1 equals 0. And then on the far right, opposite of positive 5 is negative 5. Subtract 5 on both sides. That gives me x minus 5 equals 0. So my factors are x plus 1, x, and x minus 5. But I'm going to put the x first. Then x plus 1, then x minus 5. This is going to be my function. And so we distribute. It's going to give me x squared plus x. Bring down the parentheses, the x minus 5. Right, and just making sure we're keeping track, right? This is the blue one. This one was the red one. This one was the purple factor. Okay, now we're going to multiply again. So x squared times x, that gives me x to the third. X squared times 5, times negative 5 is negative 5x squared. Then we're going to do x times x. It's positive x squared. X times negative 5 is negative 5x. So one more step, combine like terms. What's negative 5x squared plus x squared? Negative 5 plus 1 is negative 4x x squared minus 5x. And then bring down the function notation, which we can write up here as f of x equals x cubed minus 4x squared minus 5x. All right, I think there's two more examples, so let me slide over. Oh, over here. Okay. The last thing is the rational root theorem. If the polynomial p of x has integer coefficients, again, coefficients are numbers that are in front of the variables. Okay, so that's what a coefficient is. So if a polynomial has integer coefficients, integer means positive or negative whole numbers, then every rational root of the polynomial equation, p of x equals 0, a root, again, is what we use as a term for x-intercept. Every rational root of the polynomial equation p of x equals 0 can be written in the form p over q, where p is the factor of the constant term and q is the factor of the leading coefficient. So we have this p and this q. So let me color these. We have this p and this q. And so we're going to practice finding the p's and the q's, and I'll kind of explain. We're just going to practice with two examples. So there's a typo here, if you haven't noticed. It should say example 7. It says 1, I think. You can cross it out and put 7. For examples 7 and 8, determine all possible rational roots, p over q, given the following polynomials. Show all your work. So the idea here is, what is going to be your p, what's your q? So again, p's and q's, p over q's. So p's come from the constant term. So if I look at all the terms, I have 1, 2, 3, 4. 4 terms. The constant term is the term that doesn't have an x on it. So in this case, it's positive 6. This is my p, what we're going to call my p value. And then the q is the number in front of the term with the largest power. So which term has the largest power? The power of 3. What's the number in front of that term with the largest power? That's 2. So 2 is the value of q. So I have my p and my q. And what I want to find is all the possible divisions for p and q in this case, right? So, but what I want to look for is all the factors of p and q. So what I like to do is, if I have p, for example, then I can figure out all the possible multiplications for 6. So I can multiply 1 and 6. I can also multiply 2 and 3. But couple of things that we want to do. I want to put them in order from smallest to greatest. So instead of writing 1, 6, 2, 3, I want to write it as 1, 2, 3, 6. So I'm going to change the order here. So 1, 2, 3, 6. Okay, so these are the different numbers I can use to multiply together to get 6. I can get 6 by multiplying 1 times 6. I can get 6 by multiplying 2 times 3. Now one last thing we're going to do is we're going to consider all the possible positive and negative scenarios for this, or all the positive and negative values that can come out of there. Okay, now for the cube, well, there's only two numbers to multiply to get 2, right? 1 and 2. So we're going to consider the positive and negative, positive and negative. Okay, so now that I know all the multiples for my p and all the possible multiplications for q, then I'm going to look for all the possible ways to divide these two. So if I divide p divided by q, what are the different divisions I can get? Okay. So the way I like to do it is I can divide, since my q is 1, I'm just going to look for all the divisions of 1. So what's 1 divided by 1? 1, comma. What's 2 divided by 1? 2. What's 3 divided by 1? 3. What's 6 divided by 1? 6. Alright, so we've divided all the p's, by the q value of 1. Now, let's divide all of the p's by the q value 2. So 1 divided by 2, that's 1/2, comma. What's 2 divided by 2? That's 1, but we already have 1. Okay. 3 divided by 2? That's 3/2. And then what's 6 divided by 2? That's 3, but we already have 3. So these are all the possible divisions of p over q. And then I'm just going to add a plus and a minus on all these, because we're going to be considering all possible situations, so we're even considering the positive and the negatives. So this is my answer. So again, we're trying to determine all the possible ways to divide p over q. So first we have to figure out which value is my p, which value is my q. Then I figured out what are the different ways that I can multiply. What are the factors of 6 and what are the factors of 2? Then we divided. We found all the possible ways to divide. So we ended up with 1, 2, 3, 4, 5, 6. 6 times 2, because we're considering positive and negative, so we have 12 options here. All right, so let's look at the last example here, number 8. One more p over q situation. Okay, so again, remember the p term is the term without an x. So usually the last term. So p is here. And q is the term with the largest power or exponent. So x to the power 4 is the largest. So the number in front is 2, so this is my q. So if I look at my value of p, what are the different ways to multiply to get p, to get 12? I could do 1 times 12. I could do 2 times 6. I could do 3 times 4. I think those are all the possible ones, right? So I'm just going to write them in order from smallest to greatest. So 1, 2, 3, 4, 6, 12. Okay. And then we're considering all the positive and negative okay. Now let's do q, which is 2 again, so it's just 1 times 2. That's the only way to get 2. So positive, negative, positive, negative. Now, what we're going to do next is try and find all the possible divisions for p divided by q. So 1 divided by 1, 1. 2 divided by 1, 2. 3 divided by 1, 3. 4 divided by 1, 4. 6 divided by 1, 6. 12 divided by 1, 12. Okay, now divide all the p's by the q value of 2. 1 divided by 2 is 1/2, comma. 2 divided by 2 is 1, but we already have 1. 3 divided by 2 is 3/2. Let me zoom out. Space there. Okay, so I did 3 divided by 2 is 3/2. 4 divided by 2, that's 2, which we already have. 6 divided by 2, that's 3, which we already have. And 12 divided by 2 is 6, which we already have. So it's going to get down plus and minus on all of them. And that's going to be my answer. And next class we're going to talk about what all this is for, right? Why are we finding all these p's divided by q's? And we're going to put it all together next class. But for today, we're going to end with just, finding all the possible ways to divide p divided by q. All right, well, thank you for joining me. I'll see you guys next time in class. And if you have any questions, feel free to bring them up during the class next time. Have a great day.